Okay, so in the last two tutorial, we went through STM32 Cube IDE environment, and then we tried the GPIO and using the switches on the board to perform some very basic tasks. But as you move forward, um, you will encounter some problems that you need to investigate, and you need to find why something is not working or why something is working. Okay, so in that case we need to use a tool that we call a debugging tool to debug the program. If you have ever write any program in C++, in Python, in Java, you probably encountered this phrase, and you probably used it, even if maybe you don't remember the name or you didn't know the name yet. So, what is debug? What is the debugging um, tool? Okay, so let us start our program. I have a very basic program here that's basically you press a button and then it will turn on an LED uh, and turn it off basically. So let's try to run this program, and let me just make sure it's working on my board. So that's the button that you press when you want to run the program normally on your board. Okay, so I have it here, and when I press the button, it show it's turn on the red LED. Okay, so now let's debug it, and let's get familiar with debugging. So for debugging, you need to press this button here, or you can alternatively go here and then click on debug as a STM32 Cube application, or even you can click on debug configuration, and basically in the next window you just select from here the GPIO or the project name that you have, and then you click debug. Okay, so let's press that and let's see what will happen. Okay, so the first thing it asks you is that it wants to switch the perspective to the debugging perspective. So perspective is the environment that you are seeing here, and I click on switch, so it switched to the debugging perspective. So basically in debugging perspective you have some more tools to use, which I'll tell you about them shortly. So the first thing that happened, you can see there is an arrow here, and it stopped basically on the first line of the code in the main that we have. So it's HAL underline in it, and your code is basically stopped here. So in debugging, one of the first tool that you have is step-by-step debugging. So by step-by-step, we mean that you can run your program manually. You can just run one line, then run the next line, then run the next. So basically you are controlling how the microcontroller is running the code. So that's one of the features that you'll get in debugging mode. So for example here, the program is stopped at this line of the code, but you can basically click on step over, and it will jump to the next line. Okay, again step over, it jumps to the next line. You also have another feature. So if you click on step into, it goes to the function. So you see here there is this HAL underline in it, and if you if you press step over, it just run the whole function for you and skip the code inside. Skip, I mean, it doesn't show you. It run the code inside, but it doesn't show you. So it doesn't show you the codes that are running inside this function, and it basically jump to the next line. But if you press step into, it go to that function you can see here, and it basically showing you the the internal the internal codes of the function basically. So um, yeah, that was the step into. Okay, so we talked about step into. So step into will go through the function, and it basically show you the instructions that are running inside the function. A step over basically goes over the function. It means that it run the codes inside the function without showing it to you. And step return basically goes to the end of the current function that you are going. So I'm inside the MX GPIO init. If I press step return, it just goes out of the function that I was running. And then run to line, basically you tell the microcontroller to run the code until a certain line, which you can try yourself, but you need to have several lines. For example, I don't know, let's add some code, but I need to run the code again basically. So GPIO toggle LED green, LED green P. Okay, so let's just quickly stop the program, run the debugging mode. Again, it asks you for changing the perspective, so you say just switch, and I will choose remember my decision, so I won't see this confirmation dialog anymore. So I press switch. Okay, now I say I use the run to line. So basically I come here and I press run to line. You see, it just quickly jump here for you. Not jumping, sorry. It just run all the codes and stop here for you. Okay, so that's run to line. Then what else we have? Yeah, step into selection. So you select some line and step it for you. Okay, so that was the important things about the debugging. Okay, so I can basically ask the microcontroller to resume the program, so it will automatically run the program. So you see it's running the program now, and I can see green LED blinking. If I press a button, I can see a red LED turn on. If I release the button, I can see the red LED turn off. So that's what I can see on my board. Okay, so so the program is running normally now by the microcontroller. But what if I want to ask the microcontroller to stop on a certain line for me? For example, I want the microcontroller to stop here. So because your program is running at the moment, you don't have these stepping functions, and you need to use a tool that we call it breakpoint. So breakpoint tells the microcontroller to stop running the code at a certain point. So if I double click here, basically I insert a breakpoint in the real time, and if the microcontroller reach that line, it will stop. So for example, now I put it here and it came here and stopped here. Okay, so let's remove it. Let's run. Oh, sorry, I pressed the wrong button. Again, let's run the code. Oh, okay, so I think it's automatically restarting. Okay, yeah. So for example, let's put it here and then run. I mean resume. So you can see it stopped here. So I double click again to remove that breakpoint and I say resume. And you can see it's running now, but I can put a breakpoint here. It doesn't stop. Why? Because I have an if here, and if I press the button, then my controller reach this line and then it will stop for me. So you see, if I press the button now, it reached this line and it will stop here. So that's the usage of breakpoint in your code. Now let's make it a bit more complicated by adding some variables. Okay, let's do that. So I write a code. I want to write a code that if I press the button 3 times, then it turn on the LED red, okay? And if I pressed the button 3 times again, it will turn it off. So there are several ways to do it, but basically I want to do the simplest thing that I can think about it now. So I'll make a new variable here. So I'll go for the private variable section. I make a push counter. I assign it 0. Then here I just basically write, I use this code, or yeah, I just copy this code. Then I change this line to push counter. So if you press Control space, it will auto complete it for you. So if the push counter was 3, basically the code that I wrote here is toggling. So if I press it 3 times, toggle. If it was on, it will turn off. If it was off, it will turn on. So basically the code is very easy. I just write it here. Hal GPIO toggle, and then LED red GPIO. Okay, and then LED red pin. Okay, so that's basically the code that we want. Okay, but it's not that easy. So we should write a code here that will say if the user press the button, then push counter will increase. Okay, so that's it. Let's clean these lines and let's see what happens. Okay, so I know this code has a problem, so you can basically guess it now, but I just want to show you the procedure for debugging. Okay, so let's run the code. Okay, so it's running now. Okay, now if I press the switch even once, it turns on the LED. And it doesn't matter how many times I press it, it's not working properly. Sometimes it works and it turns it off, but it's kinda like randomly. So let me record the video and show it to you. Okay, so if I press the LED, sometimes it works, sometimes it doesn't work. So it seems like it's not working properly. You can try it on your board. So let's debug what's the problem. Okay, so I put the breakpoint here and I run the program in debugging mode. Okay, it's running at the moment. So I press the button. Okay, stop here. If you look, it's 3. Yeah, it makes sense because the push counter is 3 now, okay? But let's put it here. Okay. Let's push it several times. 2, 3. And now I pressed it 3 times. And now let's look at the value. it's 188. Why is that? So first tool, another tool, basically not the first tool, but another tool in the debugging mode is that you can just bring the cursor of the mouse on the variables, and you can see the real-time value. So here, push counter is 188, and we need to find out why that happened. So let's discuss it a bit. When this code is running, it's going very quickly. So everything runs very fast here. Basically, I can tell you that it will run almost like million time in only 1 second. Okay, so in 1 second, it will go like million times here. It will go like it will run this code for million times. So when you press the button, when you just hold the when you pressing the button, basically there is a small amount of time that your hand and basically your finger is pressing the button. The code will run, so it will check here, for example, first time, okay, you're pressing the button, it will add the counter. Then in a like few milliseconds later, it will go again and come here again. It check your hand is still on the button because you cannot react so fast, so you cannot just release the button in less than a couple of milliseconds. So your hand is still on the button, so it will increase it again, then it will increase it again, then it will increase it again, and eventually you take your finger off and it will stop. But in that period that your hand was on the button, which was, let's say, maybe 100 milliseconds, let's say, it ran this code 100 times or million times, and it the push counter increased a million time or even 100 times. You are seeing it 188, but probably it increased million time. It just overflowed, so it reached probably 255, and then it go back to zero. And anyway, like randomly you were seeing 188, so probably it went up and down like a lot of times. So it doesn't matter. So you understand the problem using this basic tool of going over a variable and seeing the value. There is an alternative way that you can see the values. Basically, you can come to the expressions here and write the name of the variable. Okay, push counter, and yeah, you can see the value. Even if you stop somewhere else, for example, if I force the microcontroller to stop here, still you can see the value. But the interesting thing is that it's not increasing anymore, but it's not very weird because I'm not pushing the button. Okay, so we found the problem. Okay, how to solve the problem? So what I will do here is that if we detect the user pushing the button, we will increase the push counter, but we will wait for the user to take his finger off. So just imagine just imagine now you're pushing the button, will increase the push counter one number, like 1 unit, and then will stop until you take your hand off. So that's what we want to write now. While pin GPIO pin 0 was 1, just do nothing, just stay here. It's equal to doing nothing, like this. So while user keeping his or her hand on the button, don't do anything and just step here until I take my hand off and I push it again. Okay, so that will probably solve the problem a bit, but there is one more thing as well. So let's try it. Okay, so I remove this breakpoint here. I press the button 2 times, 1, 2, and let's see the value. Okay, apparently it's okay. So if I press it again, yeah, it turned on the LED. 1, 2, 3. 1, 2, 3. Why it's not working? Let's stop the code. Look at the value. Oh, it reached 9. So basically, we need to reset the push counter when it reached 3. So this this line of code will happen again then. So let's reset the push counter to 0, and that's it, I think. Okay, let's push the button 3 times. 1, 2. Oh, with the second push, it reached 3 and it turned on the LED. Let's stop the code here and see what's wrong. It's 1. It's weird, right? There is explanation for this. So let's just try to turn it off again. Doesn't turn off. Why? Oh, it stopped here. 1, 2. Okay, it's turned off. 1, 2, 3. We turn on. 2, 3. Turn off. Okay, sometimes it works, sometimes it doesn't work. Okay, the problem is that when you are pressing a button, mechanically, if we talk mechanically, before that contact, that metallic contact that we have inside the button reaches the other end of the button, it may, like, let's say, make contact several times. Let's search something here. Maybe it can help us. Okay. Button debounce. So let's see. Yeah, exactly what I want. So when you press a button here, oh, sorry, it's on another monitor. Sorry for that. Yeah, so if you search for button debounce, and if you press a button, basically what happens is that it doesn't go straightly from 0 to 5 volt or 1 or whatever you have, and in our case it's just 3.3. So it doesn't go straightly to that value. What happens is that it go up and down because of the mechanical structure of the pins, okay, of the button side. So this is what will happen. So it goes on, goes off, goes on, goes off, and then it gets stable. So this is a real uh, probably figure recorded by oscilloscope, or this is also another one. So you understand the point. So what happened is that when you press the button in our code, we detect that pressing and then we will wait. But the thing is that in real life, that might goes on and off for a couple of milliseconds. So this called basically debouncing. There are different ways to fix this problem. For example, you can add a low pass filter uh, in your hardware, but there is a small trick that we can apply here. So what happened is that we say after the user pressed the button and we waited for the user to release the button. Basically, before waiting, we just add a bit of delay. So why we are adding a bit of delay? Basically, we are here when we detect the button pressed. So we'll wait a bit and then we'll check if the user is still keeping the button or not. And basically we are skipping this time, okay? But 100 is very long, let's say 10 milliseconds, okay? So that probably solved all the issue that we have. So this is called software debouncing. Um, and as I told you, we have hardware debouncing as well. Okay, so let's try the code, run it. 1, 2, 3. Okay, worked. 1, 2. Again, it's turned off on 2. 1, 2, 3. 1, 2. What is happening? Again. 1, 2. 1, 2. Probably when we reset the push counter and my finger is already on the pin, it will increase it again. So let's try this first. Let's add a bit of more delay. Maybe 10 milliseconds is not enough. Okay, so let's press it. 1, 2, 1, 2. 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay, so apparently it's working now. 1, 2, 3. 1, 2, 3. If it's not working in your case, try to fix it with adding a bit of more delay after and before this code. Will probably improve, because I saw the first time that I pressed the button it was not working properly. Okay, so 1, 2, 3. Now it's okay. 1, 2, 3. Now it's okay. 1, 2, 3. 1, 2, 3. So now it's working in my case. So using these delays, we basically removed these times here. Let's say here we removed this part, we skipped basically this part. But for example, before adding the second delay in my code, probably we catch this we skip this part and then we stayed here, and then again we had kind of this problem. So that's why I didn't, like, I had a problem at the first. But with this delay, we basically, when the user pressed the button, we wait a bit, then we check if the user is still keeping the button down. When user finished keeping the button down, we'll skip a bit again to just skip this part. So just imagine this. We are here, we skip this part, then user is keeping the hand on the button, then user release it, we skip again this part, and then we'll check it again. Okay, so that makes sure that we skip these two parts and it eliminate these errors that you can see. Okay, so let's talk about the last thing. Okay, the last thing in debug, which I think is necessary to know, is that you want, maybe there are some times that you want to stop at a specific value. So you want the code to stop when the push counter is true. So let's, sorry for this, it's the reminding me to stand up and take a bit of break. Okay, so let's put a breakpoint and put a condition for it. So we put a condition that if the push counter was 2, then stop here. So let's run the code. Actually, I didn't need to stop it. It's because Adding breakpoint is basically dynamic, so if you add it, it will add it right away to the microcontroller, and it will stop. Okay, let's run the code. Let's push the button. So 1, 2. Okay, so you see the push counter is 2 and our conditional breakpoint stopped here. Okay, so that's the in my opinion, that's everything you need to know for the debugging. Basically, it was an introduction to the debugging tools that we have in STM32 Cube MX IDE. Okay, thank you so much. See you in the next one.